Oh, yes, it's starting. Okay, let me share my screen. Oh, sorry, it's still on computer audio. Horrible. Okay. Oh yeah, my background is League of Legends because I'm a big weeb. Anyway, awesome. Hello everyone. Let me present this. Hello everyone. We are gathered here today as I am your guest lecturer from Cloud at Cal. So just to introduce myself again, I actually didn't introduce myself yesterday at the meeting, but I will today. I'm Hannah. I'm currently a third year studying data science, minoring Asian American studies. I am the VP of education for Cloud at Cal, WDB's sister club. That really, we haven't really done anything until now. But yeah, Samarth and Vicky have been very close friends with me. I love them dearly. So I'm here to discuss the introduction of cloud computing. I'm actually not sure how much or if ever WDB has talked about it, but I will start from the very beginning on kind of just like general cloud tech. I was hoping to get through lectures 1, 2, and 3, which lecture 1 is just introduction. Lecture 2 is the AWS IAM, AWS EC2. Lecture 3 is AWS S3. So although that doesn't really, yeah, that definitely does sound kind of a lot. We'll see how it goes. I'm gonna keep time. I'll keep time right now, 7:30, and we're planning on ending, I think, 8. I'll keep it that way, maybe. Wait, no, let me check the time real quick. Oh, 8:30, my bad, my bad. But yeah, so we'll see how far we go, but here we go, learning about cloud. Oh yes, wow, agenda for this lecture. Wow, overview of clouds, what is cloud, different types of cloud, why use cloud, and then more about how AWS works. And then, okay, we're probably gonna skip a lot of stuff because there's gonna be a lot of syllabus stuff related to CLAC. Wow, wow, that was me. Wow, our syllabus. Wow, we're still a club. We care about you. Wow, wow, wow. We also have labs. I don't think you guys will be doing labs. Uh, but if Samarth wants me to, I will send some. But and oh, final project. Wow, any questions? Wow, great. Speed running. But yeah, okay. I see it says EC2 lecture 2. Don't mind that. We just really don't update our slides in this club, but we're going to be discussing what is cloud. Awesome. So here's like an analogy I really like to use. I really like to compare it to art. So let's say that, you're an artist or something, you want to create some cool art, you've only been using crayons, and crayons are cool, but you want to get fancy with it. You want to get bougie. You want to use watercolor, right? But then you don't got watercolor. So how would you go about accomplishing this? So you got two solutions as listed here. You could either one, borrow or buy your own watercolors, or two, borrow someone else's. So yeah, breaking down that analogy, the first one, I'll go back to the other slide actually. Yeah, the first solution here, oh, my mouse, love her, the ooh mouse. But here we see the first option here, buying your own watercolors. It's analogous to buying your own servers to host like your own stuff, right? And sure, that's cool and all. And oh wait, no, I'll keep saying the analogy. No, yeah, buying your own watercolors is like buying your own servers. Borrowing someone else's is like borrowing space on the cloud to run your shit. So I guess here we kind of talk more about it. Yes, yeah, the cloud is solution two, borrowing someone else's. And the reason why we necessarily don't want to buy our own watercolors or buy our own stuff, right, is like now you got a bunch of watercolors or you got a bunch of servers, right? And sometimes if you only use them once or only use them for, I guess, that one moment that you really needed them for, like that one time you really want to do cool art, it's kind of not worth it because now you just have all these servers or watercolors laying around and now you don't really know what to do. Or if you need to use more, you buy more, but then it's like you don't really need it afterward. So, oh, not the NFTs. I see your comments. I saw you guys do that for your hackathon. That was or someone did, and I was like, whoa, that's pretty dope. Totally off topic, but yeah, so that's kind of that. I hope that analogy kind of gives a good analogy to like kind of what cloud is. Oh, here's more about the analogy. So yeah, buying your own watercolors, buying your own servers, borrowing someone else's watercolors. Yeah, renting storage space on the cloud. And here I think we pulled this definition from this random website, but Here's a more formal definition. Cloud computing is the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or a personal computer. It's definitely just, this is the reason why even cloud is just like a big major thing nowadays. And yeah, before I get more into it, I'll, I guess, go more into some terminology that I might say or might not say throughout my lecture today. So yeah, on-premise. On-premise means like you buying your own servers, maintaining your own servers, you're incurring all the risk with that management. And the word cloud, someone else is handling the service for you, and you only have to configure them. Cloud is in I guess we literally gave a definition on the earlier page, but I guess this is just like to help you guys think more about the word cloud. But yeah, so moving on to different types of clouds, we're gonna get, kind of meta with it. Here we got some cirrostratus, cirrocumulus clouds. So these are some really high level clouds, like way up in the fucking sky. So here we got, this is really analogous to software as a service, or SaaS, if you've probably heard. This like includes examples such as Microsoft Office, Gmail, Google Docs. Maybe when you think of the cloud, that's kind of like the first thing you think of, right? And the whole, I guess the catchphrase of this whole thing is like, oh, don't worry about the implementation, just use it. Like you literally don't have to like really think much about anything with this type of like tech. Awesome. And then going on to mid-level clouds like nimbostratus, altostratus, altocumulus clouds. These are mid-level clouds. This is analogous to platform as a service, PaaS. This will include examples such as Heroku, Google App Engine, AWS Elastic Beanstalk. And what kind of like this platform as a service is like, oh yeah, okay, now you have to worry more about the implementation, right? But you don't really have to worry about configuring like the operating system. And then lower level clouds, Stratus, Stratocumulus, Cumulus clouds. This is infrastructure as a service. So this is literally like Amazon Web Services, Google Cloud Platforms, Azure as a whole, like that, just like their whole offering, right? Like you kind of like have to kind of deal with everything, but don't worry, fam, will handle the hardware. Like you still have to figure out how the pieces, the microservices go together, right? But they really handle all of like the stuff that you like, the actual physical servers. Oh, why is it not clicking? Oh, or my favorite cloud, the ground. It's not even a cloud. But yeah, this is basically building your own infrastructure. Anything, this ranges as examples of anything from like your actual servers to your laptop, and you just deal with everything, bro. Absolutely sucks. Don't recommend. But here is a cool graphic that my past head of education made, kind of showing these different levels of like, platform as a service, or software as a service, platform as a service, infrastructure as a service, and then you're a cloud here. That's you. That's you guys. But yeah, that kind of helps visualize a little more about how, or different ranges about cloud technology. Oh, and here's like also a very cool visualization that we like to use. Kind of has like on-premise, like we talked about earlier, literally being the ground where you have to handle everything. And the software as a service, they literally handle everything. So yeah, that's kind of ranging like when you're thinking about creating something, or like what I guess it's really big when you're, or knowing all of this is really big when you're like consulting, I guess, or in my experience, that's how it's been, because everyone's always discussing like, oh, do we want the software as, like they always throw out those words, like SaaS, PaaS, like IaaS, whatever the fuck they say. But yeah, so here are where the next part of our lecture is ways to utilize cloud. Let's see. Okay. So here we have option 1, full cloud usage. This is using platform as a service and infrastructure as a service only. This is used to build a software as a service from the ground up with little or no infrastructure, popular with startups, simple SaaS software, new products. These are yeah, this is like what I'm going to say right now is definitely going to be very big for you guys. Like if you ever want to like explain the advantages of cloud, definitely used a lot, because before I was head of education, I was one of the head of the development branch. So talking with clients and having a lot of clients not really know the power of cloud, like, people will know like the buzzword cloud tech, but they won't actually like know what these benefits of how you could really use it for like their company for their benefit. So this is kind of like based off of like that experience that we've had. And then here we have like another way to utilize cloud on-premise only, or here's another way, like, yeah, on-premise only, sometimes just called the private cloud, right? Using on-premise services to deploy private cloud infrastructure, popular with any industry with a lot of sensitive data, also popular with high regulated industries. Oh yeah, one of the biggest things hands down that we faced as like a club doing consulting work is that um no company will ever trust you with its data, but if they really want to migrate onto the cloud, they really have to, give that data. So presenting that option like this, like, oh yeah, this is kind of like this is like an alternative to kind of help you. That's kind of that's what we like to say. And also, dude, the amount of like NDAs, insane. Oh yeah, okay. I think there's only 3 options here. Let's see. Option 3, hybrid. This is a combination of the previous 2. These are popular with really old companies. These are like companies who like can't get their shit together. Like banks. Oh, our Raj is our current head of development, and he's like a business major, so we always clown on him in this club. But there's a lot of business majors, but somehow we always just clown on Raj. Anyway, Raj is not gonna watch this, but Raj, we love you, I swear. And then also popular with companies with a lot of legacy servers, also like banks. Let's see. Oh yeah, okay, that was only 3. Here are some more reasons to why use cloud. Oh no, not Raj again. This is a photo of Raj. I always forgot that he's here. Haas reason number 1. Oh yeah, this is also what we love to tell our clients. Trading capital expense for variable expense. So kind of what that means, like capital expenses mean like, the upfront costs, like paying for the servers, those server engineers to maintain those servers, like all those costs that come with like actually buying stuff, and then versus like variable expenses. So this is where the cloud comes in, right? Like cloud, especially AWS, which we teach definitely a lot since that's the only thing we really had, or what's the word? Really had a experience in. So especially with cloud platforms, it's like, oh yeah, you only pay as you go, and you only pay for what you use, right? So it's really hard to like overpay, because yeah, if you don't use it, why pay for it? It makes a lot of sense. Haas reason number 2. So here with cloud, you're benefiting from the economies of scale. We love using big ass words here. But so the benefit of why like they're able, or AWS GCP is able to keep their prices really low, right? Is that you're not the only one using the cloud, right? Like the servers are shared with thousands to millions of customers. So cost of service are also being shared. Unbeatable savings. Wow, thanks, Raj. Wow, you guys are really getting to know our club real fast. And I think this is the last reason for Haas reason number 3. Cost. All your costs as a client is spent on that software, not hardware. So this is literally kind of what we said for the past 2 reasons, but but yeah, lots of money is actually spent not only on servers, but server engineers to maintain them. Not only are servers expensive, but server engineers are more expensive. And like as a business owner, you're like, wow, I'd rather spend this money on like software instead, right? More bang for your buck, greater focus on the product. You don't really have to focus too much on the hardware. Awesome. Okay, now moving on to our EECS reasons. So this is more of like from the computing side, right? The development side. So eliminating under and overutilization. So yeah, only use what you need, similar to Haas reason number 1, you pay as you go. And because of that, don't overpay for service you don't use. No more worries about underestimating demand. Yes, very fair. It's definitely always, yeah, available. Haas reason number 2, faster deployment of product. So yeah, this kind of goes, yeah, hand in hand with Haas reason number 3, right? Where since you focus all your money on focusing more on the product, you're able to just also faster deploy those products, right? You don't have to wait for like, oh yeah, the engineers to kind of fix it to get it ready. Like it's just like that. And yeah, on-premise requires a setup of the operating system, visualization, networking, horrible. Also includes setting up and changing hardware. Yeah, absolutely horrible. But yeah, now with like cloud, you could literally deploy in minutes and not hours. Wow, saving on time. EECS reason number 3. So global development immediately. So yeah, handling global infrastructure, absolutely terrible, right? Needs a lot of data centers, needs a lot of servers, needs a lot of networking. But with infrastructure as a service cloud providers like AWS, they do it for you. Go global, literal minutes and not years. Wow, such a difference. Awesome. I have this board for any questions. If you guys feel free, if you guys want to type in the chat box or anything, but also you could always text in the chat box whenever, and I'll read it out loud sometimes. But yeah, next part of this lecture, AWS global infrastructure. So yeah, this is going to take more of a deep turn of how AWS works. So I'm just going to mentally prepare myself for that. Let's see. Boom, why AWS? So I kind of explained to you guys earlier that literally we teach AWS simply because it's the only one that we've had really big experience in. But yeah, so when our clients come up to us and they're like, why AWS? And then we literally spew out this entire slide, which I mean, like, AWS literally, yeah, look at the dude, just look at this chart, bro. This, why is 33% of all these websites hosted on AWS? Literally the standard, right? But yeah, also I guess Azure is here, Google Cloud. Literally, I know one time a client, this is so off topic, I'm so sorry, but a client came up to us and was asking us to use like all three of these at once with their Oracle product, and I thought we were going to die. And I was just like, sir, I think it would just be a lot easier if you used one provider. And I thought that was because yeah, it's literal hell trying to fit all these into each other. Like, it's already hell kind of almost fitting microservices within one provider to each other. But anyway, I digress. I'm on the topic of why AWS. Oh shit, that rhymed. Anyway, but yeah, why AWS? Global leader in cloud services, has a global network composed of data, supports an enormous community of software developer partners. Oh yeah, definitely. That's also like a very underrated part of AWS. So not only is it like the literal global standard, like the community is so big, so like if you have an issue you could really hit up a lot of people, or like they have like a lot of support that you could go to. And also they also just have like a really cool free tier for developers. So like I know our final project is really based on their free tier stuff. You could do a lot with their free tier stuff, like I think you could host like a Minecraft server, but like I think I did that for one of, oh yeah, I did it for my lecture too, which I'm not going to do for us, but I think you could only host 2 people on the Minecraft server for free, but you know, you still can. But anyway, boom. Oh yeah, cool graph. So in the back here, you'll see, I think these are availability and edge zones. Anyway, I'll get more into that. But basically the question is, yeah, who's running Amazon Web Services? Well, Amazon. Amazon owns a lot of data centers around the world, as you see on this map. Some data centers are also rented out by Amazon. And so how they kind of split up all these data centers so that when you guys use it, you guys definitely have to like be aware of where you're deploying all your microservices. But so storage and compute is hosted in regions. So regions, I'm trying to think. I think I go deeper into it, so I'm gonna wait actually. But each region has availability zones and edge locations. And I know that our curriculum for Cloud Cal is really dependent on like the practitioners course, right? Like, so everything we're teaching in throughout our curriculum is based on like the AWS practitioner course. And they are like, they're so serious about knowing like regions and availability zones. Oh yeah, I'll get on to I see your comment of what's an edge location. I hope that the next slide says all the definitions. Yes, I'm correct. It's been a while since I've seen these slides. But yeah, so I mean, right here is not edge location, but I'll start with the biggest part, which is the region. Then I'll go smaller. So here we have the region. Oh no, not my Discord popping off. But here we have region, just yeah, geographical location in the world. And these huge regions will have availability zones and then edge locations. So each region is isolated, so no sharing of availability zones. Like 2 regions cannot have the same availability zones or edge locations. They're governed by different country or state laws, which is like kind of wild, honestly. And not every service is in every region, which is also very wild. Because yeah, I'm trying to think of the example. I can't remember off the top of my head, but there are like some microservices that you can only deploy in like Oregon, where I think it's called US West 1. Yeah, that's the region. Um, I'm trying to think, maybe it's EC2, some parts are EC3. Oh my god, no, S3. Oh my god, don't quote me on that. Sorry, this recording. But yeah, so it's very interesting because it's like that because they just have more storage over there. Oh yeah, more definitions about the region. So yeah, US East is the largest region in AWS. So yeah, oh yeah, also I explained here, like new services almost always release there first. And here are some region codes, like they're usually at like the top right of your screen if you use like the actual like UI of AWS, and you have to be wary because sometimes like the biggest pain is like you accidentally deploy something in the wrong region and you just sit there and cry. Oh, I say peep this cool map. Where is that the oh no, here it is. Here's the map. But yeah, oh yeah, here's it's kind of like the map I showed earlier, but here's the edge locations all around the world, the blue ones. The purple are multiple, more edge locations. Here are some big regions. Very cool. As you can see literally everywhere, bro. Really wild. Support unheard of. But yeah, now going on to the smaller section, availability zones. So these are owned, operated by AWS, actual data centers, right? They handle all the storage, the computing, and the more availability zones, the better. So, you know, like when you deploy your object, you can definitely deploy it in multiple availability zones, allows for redundancies, right? If you store in multiple availability zones, the data is more robust, right? So that kind of means that like if one area goes down, it'll still be available in the other availability or the other zone. And yeah, that type of solution is called the multi-availability zone solution. And yeah, just faster responses between availability zones. I think this part is, yes, finally, edge locations. And edge locations are mainly used for caching. They're yeah, mainly fast upload and downloads. And after let's see, oh yeah, after the first call, like first calling of like a microservice, that latency for that microservice is independent of geographical location. So yeah, like high latency like is being like able to call it faster, being able to run it faster, and low latency is the opposite. So yeah, you must enable usage of these locations, and these edge locations also depend on service capability. And I guess I also have a very cool chart after this. And I know that it's kind of confusing to at times to distinguish edge locations, availability zones, regions. Sometimes, like especially on the tests, they try to trick you about like what you could do for what. And that was definitely a lot of info I just threw at you guys. But let's look at this cool chart. Oh yeah, I think this is yeah, loading time to latency. So here we see in Sweden, there's such a high difference between a standard S3 endpoint and accessing the image using CloudFront. CloudFront's also another microservices. S3 is our storage microservice. Like you put stuff in there, you could pull or get it or whatnot. But yeah, it's kind of just showing the differences between latency on like I guess different points. Yes. Oh, any questions or slide? But yeah, we're chilling. Let me check the time. 7:50. We chilling. I shall move on. Oh no, wait, this is technically the end, I think, for because I think the rest is just logistics for our club. Wait, let me look through real quick. Oh, actually, JK. I'll talk about this simply because as you use like as a developer, this is kind of important. Like if you decide to use AWS through your own like your own coding like local laptop. So yeah, here we're talking about the client, like AWS's like interface and using Python. We love Python. Here we see we literally say I fucking love Python. Also, this was like the old education's slides, so I literally just kept that because I thought that was so funny. But yes, we love Python. Literally just pseudocode, right? Download it if you have not yet. Real easy to learn. I love it. I mean, you know, 618 says differently, but it's okay. But yeah, also I think for our assignments we try to use Jupyter notebooks. Ignore that. But yeah, so here is the most important part where AWS's Python package, it's called Boto 3. When you do developer work, you always like do everything through Boto 3. That's how you mainly access like AWS. Oh, and oh yeah, here's some things about AWS, really not applicable to y'all, but I'm gonna say it anyway. For our students, we gave them like a .csv credential file. So when we have AWS, we have to literally like email a special code to get everyone on our AWS like account, and basically that's how they log in. Let's see, what is else here? Oh no, not a live demo. Wait. Oh, I think the live demo. Oh no, the live demo is just the downloading the file and then running it on our terminal. But I do not have a file right now since I'm already on the account. But yeah, that's kind of all for this lecture. I'm gonna quickly go to our second lecture. We could do this. 2 lectures in one. This is what Samarth wanted. Samarth, I hope you're watching this. Boom, bada bing, bada boom. Here we go. Lecture 2, electric cloud compute and access management. So we're now, since you kind of know about the introduction of cloud, why cloud is good, why cloud is lit, right? Now we'll move on to 2 microservices that are very important. I think they're very cool beginner microservices to kind of teach. And let me present these slides. Oh no, not announcements. Awesome, here's the agenda. I'll present from here. Oh, where'd it go? Okay, bada bing, bada boom. So we'll first go over IAM. We'll go more into what IAM means or stands for. So there's a lot of different policies, how policies are evaluated, policy boundaries, evaluating logic with boundaries, and then we'll go into what is a server, how to access servers, and then go into electric cloud compute, AWS EC2, and accessing all of those. So let's get started. This is what IAM stands for, Identity and Access Management. Why is this a thing? Yes. So why is this even, like, why does AWS have a microservice to just kind of handle using the account? So yeah, it just kind of helps, right? Like with delegation, control, abstraction, simplicity, just better safe than sorry. AWS IAM is really such an important part. Like what I said earlier with companies really being iffy of giving, college students access to literally all their data. So AWS IAM really helps that because it could, we'll get more into it later, but it is so important since it could like tell people what they could access or have access to. And privacy, really big thing in the world of data. This is a shout out to my favorite class, the data ethics class. If you guys, it's mandatory for data science students, but I really think that every major should probably take it. I think it's really eye-opening to hear about like data issues, privacy issues, cybersecurity issues. But yeah, okay, top level permissions. This is this is kind of getting into the parts of IAM. So with IAM, these are like the highest level that you could be on an account, right? So you could literally be the account owner, the root user. You have admin access to everything. You also have access to billing information, also customer support access. And then underneath that, you have IAM users. So this is access, like these are people that you will, if you are account owner, you'd give them access to certain services, and they also have limited access to customer support. Oh yeah, and here's some more breakdowns to the like different roles. So we got the IAM users, we got like groups of users, and then we literally have something called IAM roles, which is different. And then going more into policies, where there are actually 3 types of policies: identity-based, resource-based, access control list. I do not have the definitions here, but honestly, not super important. I think we get more into it later if you're not the root user writing these policies. So yeah, IAM users, who are they? You and me. And this is what you use to actually log into AWS IAM, like we were telling you, or AWS, log into AWS, says IAM here, but AWS. So like I was saying earlier, the credentials, that's how you use it. So with every IAM user, they'll have policies attached to it that kind of say what they could access, only like a user level of access, granularity of access, and different users have different policy groups. So that's like the joy of IAM. Like if you have a certain group of developers who are only working on like the table, you're like, oh, literally you could only have access to that. But then you have a different group and you could be like, oh, you're working on the story, or you're working on the, I can't think of the word, the Lambda function. You guys could work on that only, like that type of thing, right? Oh yeah, so to define more about IAM groups, So an IAM group is literally just a group of IAM users. So for our example, for our Cloud account, we have a student group, we have a dev group, and then we have the exec group. And then you could group users into these IAM groups, and then you could assign little permissions to these groups, right? Like, so how I was saying earlier about like the different policies, like, oh yeah, like you only have access to this, you only have access to this. So this is like literally affects the whole group though. Oh, and here's like IAM roles. So this is used to delegate access to resources. This is definitely something I've just been saying the whole time, right? So like literally assigning specific resource, like assigning people to specific resources, that would be a API gateway to different microservices, designates what resources they have access to other policies. Roles cannot be assigned to users or groups. So yeah, roles are just like an overarching like separate entity. Like they're not necessarily tied to users or groups. They're just like overall. But yeah, let's see what the next. Oh yeah, now we get into policies. Here we go. Here we go. So here we have identity-based policies. This was the first one that we mentioned. So this is attached. These policies are attached to an identity. So as the name implies, so AWS will call this a principal policy. So this is like a big overarching policy. So specifies what an identity could do, like resource access, right? The microservice access delegation, what they could do with it, conditions for access, like, oh, they must be this. That's all you have to write in a policy for identity-based policies. Now we have resource-based policies. So to like not to clear up any confusion. So identity based literally attached to the user, right? You literally write it, it's attached to like an account user. Resource based, it's literally attached to the actual resource. So like say you made a table and you write a policy for that, like these are the only people who could access it. So yeah, C specifies the principles that who could access it. So specifies like user access, what people could do with that or what people can do with that resource, and then conditions for access, like, oh, they must be a part of this group or something. And then here are action control lists. So this manages access to a bucket and the objects in a bucket. So I definitely talk more about a bucket when we talk more about like storage for AWS, but this really specifies who could read and write access to both the bucket and specified objects. And then these are cool because you could just literally attach it to either the bucket or object. Oh, here we go into policy evaluation. Oh, yes. Okay, yeah, here's an example of a policy we wrote before. So just to kind of walk y'all through with this. So this function has access to IAM. By default, access is usually false. By default, most people just will not have access because that's like AWS's like default. Because better safe than sorry, right? Like that's literally the policy. And yeah, policies evaluated policies for policy and policies. If the policy allows this person, give them access. If the policy denies that person, literally don't give them access, and then boom, nice, return access. Oh yeah, so here's some like logic behind it. So if a policy states explicitly like an allow and deny, the final decision will be deny. Okay, so this is kind of confusing. I remember when I was first presenting this, like this logic is confusing because I guess it makes sense to me because I've seen how different policies work together. Because some policies could call it gets really complicated when you have a lot of policies, right? So like I said, I was giving you guys examples of like so many different types of policies. So literally each resource that you have could have its own policy, or that you work with has its own policy about who could access it. And then you yourself have policies that what you could access. So combining both of those, like you could have a policy that literally like puts more policies in it. So the logic is like, oh, if it's allow and then a deny, you will be denied. But then if that overarching policies state like allow or deny, the final decision will still be denied. And this is because, like I said earlier, AWS is extremely careful with its access to resources. Awesome. Now we're going to talk about boundaries. Wow, shout out to setting healthy boundaries, a very important thing to learn in college, folks. Very important thing. Anyway, let's see. I honestly don't have too much experience with really using boundaries. So I just know there's two types. This is pulled from the AWS website, but here we have service controlled policies, SCPs. So these type of policies defined by root user cannot be overridden or delegated unless by admins, I think. So yeah, these are like really overarching, like cover everyone maybe in this in the account. And then there's permission boundaries. These creation of delegated admins, mechanism for users to create new user roles and roles without security holes. So this is just a more open form of like allowing other people to kind of do stuff. I'm trying to think of how to better explain this. Yes. It's just like a smaller boundary. Oh, here we have, okay, more to talk about the first boundary. So yeah, the root user specifies all accessible AWS services, and they could define these roles through either blacklisting or whitelisting. I actually know, okay, that's yeah. I remember also saying like, I think there is a different term now for blacklisting and whitelisting because I'm, trying, tech is shifting to be more like inclusive because blacklisting, whitelisting definitely have some like what's the term? Like that whole idea of just like blacking out something if you don't want it is like kind of whack. But yeah, so these policies overarching cannot be overwritten by anyone else other than the root user, that literal main account owner, and a sense organization wide boundary access. Okay, now back to the second boundary, literally clarifying just a little more about it. But yeah, this is also just a more, I guess, better or what's more open way of delegating permissions without giving too much away, prevents privilege escalation, also prevents broad permissions from leaking. So yeah, this is literally just like so like someone doesn't give themselves everything, like literally access, like admin access, like that's the whole idea, that someone just can't give themselves like admin for no reason. But yes, awesome. Okay, wait, and we're gonna move on to complete access structure. We're moving pretty fast here. I'm so sorry, y'all. Oh, I see it's 8 though, so we're chilling. Okay, flow of access. So okay, more talking a lot more about the root users and the different parts of IAM. So okay, yeah, root users create delegated admins, sets overall SCPs. This is just a great summary of kind of everything I kind of said. Delegated admins, they could use user resources, can create new users and roles. So like an example, if I'm an admin, I give someone else their delegated admin, or I'm the root user, I'm the literal account owner, then I could give like my execs delegated admin access. They could literally create new users and roles like for their students or for their devs, right? And they could also set those org level SCPs or permission boundaries. And then those devs that we gave permit or access to are just the normal users. And yeah, I see here literally just 1 point of IAM levels of permission. So that definition is literally just where users' roles and permissions start having more defined meaning. Okay, not gonna lie, I feel like there's supposed to be more on this slide. I'm gonna skip over it. Okay, here we have a live demo. Actually, I'm not gonna show you guys though. Wait, I don't think I'm logged into my account. Wait, I could try showing you guys actually. Just a little bit. I think we definitely have time for it. And also like I guess it's something nice to look at other than these like whack slides. So I'm gonna go log into my cloud account. So here's the login. I have a specified login since this is our account. I don't think I know my password. I hope it like saved it. Oh, oh wait, did it? No. Okay, I think that's my password. Or I think that's my IAM username. Oh, hacker voice, I'm in. Oh, yes, beautiful, beautiful. Oh yeah, so here's the AWS page. I think the general consensus with everyone who is a developer is that we hate the page. Literally sucks. Why are all their microservices listed like this? I literally can never find anything. But oh yeah, to kind of explain here, we see the regions like I said before. So here we are in Northern California, even though I am not in Northern California at the moment, like me, literally me physically. But yeah, here we have US East 1, US East 2, and you could kind of change it wherever here. I've never had to use anything over here, literally only just US. And then here's just my IAM account. It says my name, my IAM username. And let's go into IAM. Oh, right here, recently visited services. Great. Awesome, sicko mode. Load faster. It's cause it's the a Core i5 ThinkPad that's stuck in Eastern time. But what? Is this the dashboard? Did they change it? No. Oh, Is this the dash? Okay, yeah, this is also a reason why I hate AWS. They change their dashboard like every 5 seconds. Like if you look up like AWS often puts out labs you could do, or they make like they have things that you could do, right? Like they have great tutorial documentation, but sometimes they'll show a screenshot and AWS doesn't look like will not look like that, like absolutely different. So right now I'm like, what am I looking at? Also, by the way, I really don't use the main page that much. I really only code it. But okay, so here's our login. Here we see we have 32 users. We got 10 roles. We got 3 groups. And then we got 4 management policies and 0 identity providers. So let's look at the users. I think my demo is usually I add a user and maybe I could walk through that. Usually I like give someone in the call an account, but like we'll see. Let's see. Maybe I'll just add myself again. But here we see we have a friend, we have one of our PMs. I gave him full admin access, even though usually you don't want to give full admin access, but I just gave it anyway because I didn't want to write any policies. But okay, I gave it to him 30 days ago. Here's the key access age. A lot of these people were from last year. You can see their last activity. So this man was literally on yesterday, our PM. This person has not been on in like 200 days. That's how old this club is. This person has never been on, so thank you. I mean, granted, we don't really use this page anymore since the first time we used it, it cost us, we accidentally like blew up our account, like the billing, and it costed us like so much money, and then we were so sad. But yeah, okay, wait, let me see if I can show you guys how to add a user. Oh yeah, here usually we'll just do the name. So my name's Hannah Chia. Usually we'll just do H Chia. Okay, well I exist already. Boom. You can add multiple users, access type. Usually we'll just give them what? Oh no, usually we'll just give them a password. We'll auto generate it. And then they'll have to create a new one. Let's go to permissions. Oh yeah, so here we could add a user to the group so they could have those permissions. So right now here we have full admin, developers or students. What if I make myself a student? And see here for students, they only got access to EC2 and then 2 more. The developers only have access to IAM user change password because actually they don't really develop on our account since it'll rack up our bills. They usually develop on the company's, the client's AWS account. But yeah, let's go add some tags. But yeah, okay. We're chilling here. Oh, we're not gonna add any keys. And yeah, okay, then I would create the user, but I won't since I already exist. But yeah, that's the example for IAM. But yeah, let's see, where am I here? Oh no, this is lecture 1. Okay, so that was IAM. And I think, okay, I see the time check. It is 8:10. I think we're only going on to 8:30. So I think I'm barely only going to finish lecture 2, which is fine. Because if anything, my friend Irvin could finish the rest next one. So that's chilling. Okay, I'll present. I'll wait for it to load. Boom. Moving on to our second microservices. Congrats on learning AWS IAM, y'all. Proud of y'all. Wow, really making cloud moves today. But yeah, let's talk about some computing basis. So before we could talk about the second microservice, we kind of had to understand what servers are, right? So they serve information. You know, there's a lot of different types of servers. There's a lot of different applications. To be honest, I'm not a pro at all the servers. I really don't know that much about hardware. I think there's a class for that at Berkeley. I don't know, maybe I don't recommend it. But provide services like storing media, hosting web apps and pages, facilitating emails. So that's some basis behind how you could use a server, what it's used for. Wow, this photo is just covering everything. I just really just pasted this one photo of a man looking at a bunch of servers over my thing. But there was like a meme I saw recently because I've been getting into custom or building custom PCs, and I saw like a meme where someone bought a server. I think because they had to work from home, their company just sent them the server or something, and it looked like a refrigerator. And then they were like, "Oh my god, check out my new fridge," or like, "Check out my new I forgot what it, but no, I think it was fridge. Yeah, they were like, check out my new fridge. And I was like, what the fuck? I was literally like, what's going on in this Reddit? But yeah, okay, so some more about connecting to servers. Yeah, you could use your command line literally from your terminal using the SSH command. I'm not gonna show you guys that, but I think in 61B, you guys tend to go into the GitHub like that or GitHub stuff. Um, but yeah, now that you kind of know more about servers, let's move on to the actual microservice. Oh no, it's just a live demo. Okay, I could do that. Oh my god, it's been a long time since I've given these slides. Let's see. Let's pull it up. Okay, I think I'm only gonna show you guys a certain amount. I don't think I'm actually gonna, I think because I created like a Minecraft server last time, or I SSH'd into a Minecraft server that I did on EC2. I'm not gonna do that, but I'll give the basic idea of kind of how to create an EC2 instance and then go into it on your terminal. Actually, this laptop cannot do anything. Like it actually won't let me code at all. So I'll just show as much as I can. Damn, maybe we can go into in these last like 10 minutes, maybe we can cover like the third lecture since this demo is going to be very chill. EC2 is literally just setting up a server. Let's see. Do I have any instances running? I really hope not, but that would really help me with this demo. I have none running. That's good because they rack up like a lot of money. This was why we did a homework assignment where they had to create it on our account and it literally racked up so many bills. I was so sad. Let's see. Let's launch an instance, y'all. Let's do this. I just won't go into my terminal, but okay, so we have a lot of here we have the Amazon machine images, templates that contain software configuration. To be honest, when I look at all this, I don't really understand. So don't ask me too much. I just know what I usually do and what most people encourage, but I don't know why. So we're gonna go with this one. Awesome. Choosing an instance type. We're gonna use the free one. T2 micro. Literally only hosts 2 people on your Minecraft server. And here we're configuring some instance details. Here I'm looking through. Most of the time we keep the default because we don't want to mess too much with it if we don't need to. There's something I need to turn on, I think. Oh, here we could put IAM stuff. Actually, I don't think I need to turn on anything here. But there's a lot that you could do. Like there's a lot of things. I honestly don't know what each of these do, to be really fair. But let's move on to adding storage. We're using the default. Oh yeah, and here's some tags. I don't need to use tags at the moment. Kind of helps if you're like making a bigger project and you know which parts go to which, but we're not here. Oh, okay. Oh yeah, so here's a security group. If I was actually trying to code through or attach it to my laptop, I'd actually put like a different port. I literally forgot what port I'll use, and then I would make it a HTTP, that type of thing. I think that's just I don't know, that's just been the standard I've used to go into mine. I'm trying to think. Okay, I mean, this is all hypothetical. I'm not putting anything actually, or no security. I haven't written an actual security group in it, but yeah, now we're viewing all our instances and we're launching it. Boom, bada bing. Oh, and we have a key pair here. So key pairs, this is what actually lets us get into AWS or like the EC2 instance. So here we have a key pair called fuck. I'm just gonna keep it, and then it's just gonna make us download it. Oh, it didn't make us download it. I think I forgot to click that, but it's fine. But yeah, now our instance is now running. Let's go look at it. And it could take like a few minutes. So literally sometimes I just sit here and vibe. See, it's pending, so it's kind of just like, oh, we're chilling. Here's our instance ID. Let's go look at it while it's pending, because it doesn't really matter if it's pending for this demo, since I'm not going to actually go into it, but or like connect to it. That's a better word. But here's the public IP address. Oh no, here's the public IP address DNS that usually we'll go into. That's the only one I really know. But there's like a lot of stuff for EC2 that you could kind of look through and see how to attach things to. Doing status checks if it's like working, see it's still pending. You can monitor them. There's nothing here since we're not using it at the moment, but a lot of devs will go more into that as they get like more used to it. But this is just like a general overview on this this microservice, so I'll just go more into that. I think, let's see, if it was when it gets going, we could click connect, I think. So right now we're just vibing. Oh, it's running. JK, we're good. And see, there's literally a lot of connect buttons, dude. I don't know. Get a new UI designer like for them, bro. Like for AWS, they need some help. There's a lot going on this page. Usually there is code it's much easier to do like via code, like on your local. Oh yeah, so here we are connecting to the instance. So usually I like to simply just doing the SSH through the terminal. Like we'd open our terminal and then we'd find the private key and connect to it. I think, wait, no, let's see. Yeah. And then we'd literally through our terminal, literally just like copy and paste this, or no, copy and paste this. They say example, but that's literally, you could just copy and paste this and then you send it in to your terminal and then bada bing, bada boom, you're in. And then you could like code throughout there. Or like that's when you could like more access it, whatever's in the EC2 instance, like whatever's on your server. But yeah, that's kind of that. I'm going to show you guys to terminate it though, because this is probably the most important part. Because if you do not terminate it, you will die. You'll instantly die. Your bill through the roof. I know it says free tier, but that's a fucking lie. Let's stop it. Let's terminate this instance. And yeah, there's a lot of status checks to make sure it's running, or there's also alarms to tell you like, oh, if it's when it's used, here's the availability zone, US West 1C. There's a lot of information on here. But yeah, hopefully, okay, so successfully terminated lit. Cool, very cool. Let's do a time check. So that was, yeah, just a brief overview of how to use EC2. I'm not sure if that was too helpful to you guys, but if you guys ever run into the instance where you need to create a EC2, or if the backend engineer is talking about EC2 and he's talking about like, okay, I gotta go in the server to host your shit, then you're like, oh, okay, I got a good knowledge about that. But yeah, okay, I see it's 8:20. I got 10 minutes. Let's see how much I could really cover about simple storage services. Low-key, I think I could cover this in 10 minutes. I know this is like, actually our lectures usually take an hour, but that's also because I give fat amount of like practitioners exam questions. And I know I shouldn't have to go super too deep into these microservices, but yeah, okay. Bada bing, bada boom. Let's do the speed running this one microservice 10 minutes, which is fine. People have done that before. But yeah, okay. Moving on. Now that you guys know AWS EC2, we're going on to our third microservice, which is simple storage service, which is literally what it stands for. Literal simple storage service. So yeah, what is Amazon S3? So it's one of AWS's first offerings when it was created in 2006. Literal just object storage, like stores images, text in a folder structure. Super cost effective, right? Literally like 2 cents per gigabyte for storage. But unfortunately there are access costs. So to literally get that and retrieve that information, it also costs money. But it's okay, it's still very cheap. I don't have the price here, but it's still cheap. So one of the best things about Amazon S3 is that its redundancy. Like, look at this durability. It, like, Amazon always flaunts that it has like, I think it's 11 nines of percent of durability. Like, there's a very little chance that you will lose all your data with this like S3 bucket. And also these contents of each bucket, like in the S3, it's replicated across 3 availability zones. So you really aren't going to lose your stuff. So it's very like stable. Robust is the word, I think, actually. But yeah, to kind of talk more about why S3 is useful, super cheap, reliable way to store objects, right? low latency, high throughput access, like accessing whatever in it. Easily, the joy of S3 is that you could really host static websites. So a lot of people will use EC2 and S3 to host like WordPress websites, or like if they have I know for me personally, like hosting your own personal website, very big, like probably very basic, like reason to use it. Probably the most like, what's the word? Most often used reason of S3, I want to say, especially with like front end. But yeah, so S3, the storage system also integrates with a lot of other AWS microservices. And yeah, also it's built in a way, I can't exactly explain what exactly, but it's built in a way where the older the data is, it'll be shifted into even more long-term storage to reduce, like, for cost reduction. So like if they see that you haven't accessed this data in a while, they'll like push it lower, and they'll keep the stuff that you access more often on the top. And yeah, that's also to keep costs low, because storing is expensive. Or not, it's not that expensive, but money is money anyway. So here's some more advantages. So minimal features, focus on simplicity, literally simple storage system. Like, what a clout to literally name your microservice simple storage service. I think about that a lot. Anyway, can store an literally could store an infinite amount of data in the bucket. So, and each object in the bucket could have like 5 terabytes of data. So this is massive. Like, it's kind of insane. And that you could download your data, you could access your bucket, or have others access your bucket whenever. And you could also, like we said earlier, what I am, deny access to whoever wants to access this bucket. So yeah, boom, any questions? Well, too bad we're speed running. I know I am throwing a lot of info at you guys, and it's totally chill. We'll send all this stuff out. And if anything, all the info is online. Like, just generally, like, on AWS. But here's some cool terms to know. Cool terms to know if you're speaking with your cool backend friends. Highly available. Highly available in AWS terms means across multiple availability zones, right? So it means, like, if one goes down, application's still active. The word durable means able to withstand the failure of something without downtime or data loss. When we say cost optimized, means cheap, not wasting resources, right? Scalable, also a very big part of the cloud. Like when a company wants to scale their infrastructure in minutes. Here we see Zoom. I forgot why I included that example, but scalable, if you want a lot of people to access it in the future, very good point, very good part of like cloud. Latency, like we said earlier, speed of connection between customer and cloud. Low latency is better. Did I say that earlier? I can't remember what I said, but that's the definition. Oh my God, I'm so sorry. Anyway, so here we are talking about file systems. You guys probably are pretty aware of what file systems are, right? Literally just accessing your computer on the daily basis, right? But just really controls how data is stored and retrieved. So without the file system, data placed in like any storage would just be like a large body of data where you just don't know where one stops or when it begins. So there's a lot of different ways to kind of like think of file structures, like a lot of different type of file systems. So there's like the data or the tree data structure with nodes and just like file directories, right? And the leaves are the files, or they're just null. This implementation varies between like the PS4 versus like a printer versus like Windows versus Unix. So that's just how file systems have been working. So yeah, okay, on to kind of more deeper into S3. Like I've been saying, the word objects. So objects are a fundamental entity that is stored in these buckets. So these objects that could hold 5 terabytes of data consists of just the object and the metadata. So the metadata, just a name value pair so that you could really access it. Custom metadata as possible so that you could access it. Objects are uniquely identified within a bucket with a key name and a version ID. So that's kind of how you access objects within a bucket if you are coding. And like I've been saying earlier, I've been talking so much about buckets. Here's a photo of a bucket if you forgot what a bucket looks like. But so each bucket you could think of as a directory or as a container for objects stored in S3. And each object is contained in a bucket, but buckets do not hold buckets. That's the biggest thing ever, bro. Like no directory substructure, literally just Folders are lies told to you by big file system to sell more file systems. And anyway, these bucket systems are universally unique, and you could configure buckets so that they are created in a specific AWS region. Like, if you want people in the East Coast to access them faster, you make it over there. But yeah, oh my God, more about buckets. Wow, there's so many buckets. Anyway, to talk more about buckets, they serve several purposes, right? They organize everything in the S3. They identify the account responsible for storage and data transfer charges. They play a role in access control. Buckets are literally just like anything. Literally just all that information just stored in there. And just like literal just unit of aggregation. Like I don't even I'm trying to think how to better explain this. It's literally just an abstract, such an abstract thought. But yeah, wow. Any questions? Let's see. Boom, demo. And since I love these slides I learned from my last slides to put photos on the slides for the demo. Boom. Now I don't have to actually go on my what is it? My actual web page. You guys just see it here. But yeah, this is a page for S3. Here we have two buckets, we have 2 buckets already. Oh, this is web dev at Berkeley. We're literally hosting a website. I forgot. Boom, we're creating a bucket. Here we have the bucket names, the regions. We do all that. Don't really care about configuring options. We're blocking all public access. I think that's just by default because, AWS, real big on data security, looking at reviewing stuff. Boom. I think we created one called Clack S3 Lecture 4. And these bucket objects are not public. Literally only we can access it. Created in US region 1. Boom. Wow, so easy. Nice. Let's see if we can put something in this bucket. Here we see we're going to create a folder. But like I said earlier, that buckets cannot store buckets. So like that was a fucking lie. They literally just have that there that says create a folder. But like I said earlier, here's the specification on AWS's website. You can't do buckets within buckets, but you can have folders within folders. I actually totally forgot much deeper into the reason why. I don't know. I can't explain this on like a basic level since I literally forgot. So the words are there for you to read. Sorry about that. But anyway, here we are creating a folder and we're going to select files. Boom. We literally, I think we put our one image in here. Here we have a standard, like here's different storage classes. We're literally going to make it standard, frequently access the data. Here's our one photo that we put in there. Here we're looking at public access. Here we could write more about the policy editors, who could edit, who could look at this, who could access it, whatever. Management, here we'd see more stats about who's accessing it, if it was actually attached to something, like if it was attached to like a WordPress website, that you could see how many people or how it's going, if it ever goes down. But yeah, boom, bada bing, bada boom. Oh, I guess I never show like what the photo is, but yeah, that's it. Okay, I guess here's more. This is literally the last slide. Wow, it's 8:30. Literally on the last slide. Think about Boto 3. If you guys code in Python and access like, or if you guys code through AWS on your like local computer. But yeah, everything you could do in the UI, like on the actual AWS website, you could do in Boto 3, like the Python package. It's very easy. We really like it. AWS UI without the UI, pure code, pure power. That sounds like whack, but here's like a lot of code that you guys could see. This is from the Boto 3 documentation. There's a lot that you could do. It's very confusing and hard to learn. I literally just am on it at all times. But anyway, I think that's the last of my slides. So, oh my God, I appreciate y'all for being absolute fucking troopers. Getting literally through 3 lectures. Gang. I think I'm gonna end the recording here, but thank you guys, and then end the lecture here, but thank you guys so much. Next lecture Monday. I hope this info was useful for y'all. It probably wasn't, since it's like very back end, but but thank you all for being here. I'll stop. Where's the recording?
Thank